Good morning, everyone. I am Gautami. My topic is sequential circuits in the subject of basic electrical and electronic engineering. Introduction to sequential circuits. Sequential circuits are digital circuits whose output depend on the current input and past states. They are fundamental in designing memory elements and complex digital systems. Unlike combinational circuits, they have memory and can store information over time. From the diagram, combinational circuits gives memory element. A is input, A dash is output. Basic components of sequential circuits. The primary components includes flip-flops, latches, and registers. These components stores binary information and synchronous data transfer. Control logic determines how data move between storage elements and combinational logic. Types of sequential circuits. Circuits are categorized into synchronous and asynchronous types. Synchronous circuits use a clock signal to coordinate state changes. Asynchronous circuits change states immediately in response to input changes without a clock. Flip-flops and latches. Flip-flops are edge-triggered drivers that changes states on clock edges. Latches are lever-sensitive drivers that can change state anytime that enable signal is active. The both are essential building blocks for creative memory elements in sequential circuits. State diagrams and state tables. State diagrams usually represented the states and transistors of sequential circuits. State tables tabulate current states, input, and next states systematically. These tools are vital of designing and analyze circuits behavior. From the figure, a state diagram of sequential circuits is given in the figure. Find the corresponding ASM chart. Minimize the chart complexity by using both vertex and scalar designs box. The input and the X1 and X2 are outputs are Z1 and Z2. Design process of sequential circuits. The design process starts with defining the circuit's specification and behavior. Developing states diagram and the tables helps in understanding the required states. The implementation involves choosing appropriate flip-flops and designing the logical for the state transistors. Timing and synchronization. Timing analysis ensure that all flip-flops and logic element works currently within clock cycles. Setup and hold time are critical parameters influencing circuit stability. Proper synchronization provides errors caused by race condition and glitches. Applications of sequential circuits. Sequential circuits are used in counters, shift registers, and memory units. Uh, they form the core of digital systems like CPU, control units, and communication devices. Their ability to store and process data make them essential in modern electronics. Challenges in sequential circuit diagram designs. Designing for timing and race conditions can complex and requires careful analysis. The power consumption and circuit speed are important conditioners, ensuring reliable operations under various environment conditions in also squirrel. Summary and conclusion. Sequential circuits are virtual for creating memory and state independent digital system. Understanding their components, designing method and timing constructions is essential for engineers. Advance in technology continue to improve the effectively and complexity for sequential circuits design. Thanks for giving this opportunity.